We'll start in about 1 minute. We'll continue with the test 4 review sheet. Tomorrow is test 4. Later today, I will send an email with a Zoom link for tomorrow's test. But we probably don't have time to do every single problem, so I'll do a representative problem or two from each section. Yesterday, we sketched a graph of this quadratic function. This one has a coefficient that's positive, so we know the parabola opens upward. So let's take a look at part D, where the leading coefficient is negative, so we know the parabola has to open downwards. The y-intercept, when x is 0, the y-coordinate is -2. So that's the y-intercept. The x-coordinate of the vertex, -b/2a. So this is the negative of -4 over 2 times -2. So this simplifies to +1 because -1. The numerator is +4. The denominator is -4. So the x-coordinate of the vertex is -1. To find the y-coordinate, we just use the function, replace x with -1. So -1 squared is 1. -2 times 1 is -2. And -2 minus 4 times -1, that's -2 plus 4, which is 2. And then 2 minus 2 is 0. So the vertex is the ordered pair -1, 0. Since the y-coordinate is 0, that is also the only x-intercept. Okay, but suppose we didn't notice that the vertex is also the x-intercept. To find the x-intercepts, we solve the equation that we get when we replace y with 0. So 0 equals -2 x squared minus 4x minus 2. then in the process of solving this equation for x, I would divide every term on both sides by -2 to make the arithmetic simpler. So divide both sides by -2, we get 0 equals x squared plus 2x plus 1. And then we can easily factor x squared plus 2x plus 1. The two factors are x plus 1 and x plus 1. So this verifies that there's exactly one x-intercept. In other words, this is a perfect square trinomial. So the equation has one repeated solution, and so there's only one x-intercept. So we can begin the graphing process by plotting the vertex, which is also the x-intercept. We can plot the y-intercept. That's the ordered pair 0, -2. So we have 2 points on the parabola. We know that it opens down. And we can use symmetry to find another point. So what's the other point that we can use, or that we can plot if we use symmetry?
-2, -2.
Yeah, -2, -2. Is that what you said? Since the y-coordinate of the y-intercept is -2, and we have the vertical line of symmetry, then equidistant from the line of symmetry to the left is another point, which is -2, -2. So that's enough to get a sketch of the graph of the parabola. I'll just mention alternatively, you always have the option of picking any number of x coordinates that you want, and then using the formula to find the corresponding y coordinates. Okay, but we have enough for that graph. Let's move on to the next page. So in section 9.7, we graph quadratic functions using transformations. So the directions rewrite each quadratic function in vertex form by completing the square, and then graph the function using transformations. So remember the 4 steps to get a quadratic function from standard form to vertex form. First, we factor the leading coefficient out of the x squared term and the x term. So factor 2 out of the first 2 terms. So we get 2 times the quantity x squared minus 2x. But leave the constant plus 4 on the outside. Then we'll write another step separate from the first step. So we copy what we did in the first step, but in this step, we're going to add 0 inside the set of parentheses. In this process, we create a perfect square trinomial. So we're focusing on x squared minus 2x. So take half of -2 and square that number. Half of -2 is -1. When you square -1, you get +1. But then to maintain balance, we subtract 1. So this is all we want to do in the second step. We added 0 in the form +1 - 1. In the next step, we're going to keep the perfect square trinomial inside the parentheses, x squared minus 2x plus 1. And then we can refer to the second step to know what we need to do in the third step. We need to multiply 2 times -1, which is -2. So on the outside of the parentheses, we put -2 together with the +4 that's already on the outside. And then finally, the fourth step is the vertex form. So y equals 2 times the binomial x minus 1 squared plus 2. So this is the vertex form. And we got it to vertex form in 4 steps. So for tomorrow's test, be able to show those 4 steps. Okay, the vertex is the ordered pair 1, 2. The parabola opens upward, so that must mean that there are no x-intercepts because the vertex is above the x-axis. So we have enough information to begin sketching the graph. We can plot the vertex 1, 2. We can identify what the y-intercept is. There will always be a y-intercept. When x is 0, the y-coordinate is 4. So there's the y-intercept. And we'll get one more ordered pair, and that will be enough to sketch our graph of the parabola. So I'll pick x to be 2. And then we can use the formula y equals 2x squared minus 4x plus 4 to find the y-coordinate that goes with x equals 2. Replace every x with 2. 2 times 2 squared is 2 times 4, or 8. 8 minus 4 times 2. 8 minus 8 is 0. 0 plus 4 is 4. So when x is 2, the y-coordinate is 4. So we can sketch the parabola. Notice that the ordered pair 2, 4 is symmetric to the ordered pair 0, 4. We have this vertical line of symmetry. This line of symmetry is x equals 1. All right, for the next one, let's just get it into vertex form in 4 steps. So y equals negative x squared plus 2x plus 8. So we factor -1 out of the x squared term and the x term. So when we factor -1 out of the first 2 terms, we get -1 times the quantity x squared minus 2x. But leave the plus 8 outside of the parentheses. In the next step, we add 0 inside the parentheses. So now we focus on x squared minus 2x. To create a perfect square trinomial, take half of -2 and square it. So half of -2 is -1. When we square it, we get +1. So +1 minus 1. Then in the next step, we keep the perfect square trinomial, the x squared minus 2x plus 1. And then on the outside of the parentheses, we write -1 times -1 is +1, together with the +8 that's already on the outside. And then we have y equals the negative of x minus 1 squared plus 9. Okay, so the vertex is the ordered pair 1, 9. The parabola opens downward. The y-intercept is 0, 8. So we can get a rough sketch of the parabola. This is a pretty rough sketch, 1, 9. 0, 8 is the y-intercept. By symmetry, uh, 2, 8 is a point. There are 2 x-intercepts. So maybe we should find the x-intercepts. Replace y with 0 and solve the equation. 0 equals negative x squared plus 2x plus 8. So if I were going to solve this, I would divide every term on both sides by -1. So divide both sides by -1, we get 0 equals x squared minus 2x minus 8. And we can solve this by factoring. One factor is x minus 4. The other one is x plus 2. Okay, so our x-intercepts, one x-intercept is the ordered pair -2, 0, and the other x-intercept is the ordered pair 4, 0. Okay, the next part, find functions from graphs or descriptions of graphs. So here we're told that the vertex of a parabola is the ordered pair 1, -1, and the y-intercept is 0, 3. Find the quadratic function in its standard form, y equals ax squared plus bx plus c. So in a case like this, my suggestion is use the vertex form. We don't know what the value of a is yet, but we can find that in the next step. So write down y equals a times, and then the vertex form, the x-coordinate of the vertex is 1. So we write a times x minus 1 squared, and then minus 1. And since the y-intercept is 0, 3, we can determine what the value of a is if we replace x with 0 and replace y with 3. And then we will solve the resulting equation for a. And then after that, we'll be able to write it in the standard form. Hey, do you understand what we're doing? So we're using 0, 3 in this equation. So replace y with 3. Replace x with 0. So we have 0 minus 1 squared and then minus 1. Then we're just going to solve this for a. Okay, so in the next step, we can do a couple of things. We can add 1 to both sides and then simplify the 0 minus 1 squared. So add 1 to both sides, we get 4 equals a times the number -1 squared. The number -1 squared is 1, so we get a equals 4. Okay, so go back to the vertex form and replace y with 4. And to get it into the standard form, y equals ax squared plus bx plus c, we just square the binomial and do the arithmetic. So we get y equals 4 times, and then when we square x minus 1, that's x minus 1 times x minus 1, we get x squared minus 2x plus 1, and then minus 1. And we're a couple of steps away from the standard form. So multiply 4 times the trinomial, we get 4x squared minus 8x plus 4 minus 1. And finally, the standard form is y equals 4x squared minus 8x plus 3. So that is the standard form. The next problem is the same kind of problem. Well, this time, instead of the y-intercept, one of the x-intercepts is given. In addition to the vertex. So let's go ahead and start this. The vertex is the ordered pair 3, 2. So if we begin with the vertex form, y equals a times x minus 3 squared plus 2, the vertex of this is 3, 2. And then we can use the fact that one of the x-intercepts is 2, 0, and this equation to determine what the value of a is. So we're going to use the ordered pair 2, 0. The x-coordinate is 2, the y-coordinate is 0. So in this equation, replace y with 0. Replace x with 2, so we have 2 minus 3 quantity squared. And then we can solve this for a. So let's subtract 2 from both sides. So we get -2 equals a times, and then we'll simplify the 2 minus 3 quantity squared. 2 minus 3 is -1, so we have -1 squared. But a times -1 squared is just a times 1, or a. So a is -2. So we can write the vertex form, which is y equals -2 times x minus 3 quantity squared plus 2. And then to get it into standard form, we just multiply this out and simplify. So -2, and then we square the binomial. X minus 3 squared is x squared minus 6 plus 9. And then the plus 2 on the outside. And then distribute multiplication by -2, we get y equals -2x squared plus 12x minus 18 plus 2. And then finally, the standard form is y equals -2x squared plus 12x minus 16. Okay, let's move on to the next section. We have a few quadratic inequalities. I'll just do the first two. The general process is similar in each case. So solve this quadratic inequality. Remember, for quadratic inequalities, we want one side to be 0. And then to find the endpoints, we solve the equation you get if you replace the inequality with equals. So solve x squared minus 10x plus 21 equals 0. We can always use the quadratic formula, but if you can see how to solve it by factoring, that's usually more efficient. And we can solve this by factoring. The two factors are x minus 3 and x minus 7. And you can verify just by visually multiplying that those are the correct factors. Negative 3 times negative 7 is positive 21. And negative 3 plus negative 7 is negative 10. So the endpoints are the numbers 3 and 7. So divide the number line into the 3 intervals using the endpoints. So we pick a test point from each interval. In the first interval, pick any number less than 3. Since 0 is in that interval, I'll pick 0. And then in the inequality, replace every x with 0. We're left with 21 greater than or equal to 0, which is true. In the second interval, pick any number that you want that's between 3 and 7. So I'll pick x to be 4. So you might want to consider writing the inequality in factored form. X minus 3 times x minus 7 is greater than or equal to 0. Because sometimes just using the factors is easier arithmetic. So if we use the factored form with the test point 4, 4 minus 3 is 1. 4 minus 7 is negative 3. And 1 times negative 3 greater than or equal to 0 is false. So none of the numbers in the middle interval are solutions. And then in the third interval, pick any number greater than 7. So if we pick x to be 8, this time I'll use the original inequality, replace every x with 8. So we get 8 squared is 64, and then minus 10 times 8 is minus 80, and then plus 21. So negative 16 plus 21 is 5. 5 greater than or equal to 0 is true. So all of the numbers greater than 7 are solutions. And since we have greater than or equal, the endpoints are included, because if you test the endpoints, we get 0 greater than or equal to 0, which is true. It's the or equal to 0 that makes it true. So we include the endpoints. The interval notation is negative infinity, comma 3 bracket union, and then bracket 7 comma infinity. The algebraic notation is x is less than or equal to 3, or x is greater than or equal to 7. And if you sketch a graph, you put a bracket at 3 and shade to the left, put a bracket at 7 and shade to the right. Okay, on the next page, let's do the last one, part F. So on this one, solve this inequality. Negative 2x squared minus 12x minus 16 is less than 0. Well, we can make life a little easier on us if we divide every term on both sides by negative 2. We just have to remember, whenever you divide both sides of an inequality by a negative number, you have to switch the inequality to its opposite. The same is true if you multiply both sides of an inequality by a negative. You have to change the inequality to its opposite. But here it's easier to think about just dividing both sides by negative 2. So when we divide every term on both sides by negative 2, we'll get x squared plus 6x plus 8 is greater than 0. Okay, so that looks right. To find the endpoints, we solve x squared plus 6x plus 8 equals 0. So to find the endpoints, we solve the equation we get by replacing the inequality with equals. It looks like this is factorable with integer coefficients. So one of the factors is x plus 4, the other one is x plus 2. And you can visually verify by multiplying that we have the correct factors. Positive 4 times positive 2 is positive 8, and positive 4 plus positive 2 is positive 6. So that verifies that these are the correct factors. So the endpoints are negative 4 and negative 2. When you're testing, make sure that you can use either inequality, but it might be more straightforward just to use this one, x squared plus 6x plus 8 is greater than 0. So plot the endpoints negative 4 and negative 2. And the interval on the left, pick any number less than negative 4. So a problem I've seen, not only this semester, but in other semesters, if you pick a test point from the wrong interval, when you think it's in a particular interval, that will give you, obviously, give you an incorrect result. So a number that's less than negative 4 is negative 5. We can use the factored form of the inequality, x plus 4 times x plus 2 is greater than 0. That might make the arithmetic easier, but you're free to use any one of the inequalities. If we use the factored form, replace x with negative 5. Negative 5 plus 4 is negative 1. In the other factor, negative 5 plus 2 is negative 3. Negative 1 times negative 3 is 3. The inequality greater than 0 is true. So all of the numbers in the interval from negative infinity to negative 4 are solutions. In the second interval, pick a number between -4 and -2. So we can pick -3. This time I'll use the non-factored inequality up here, x squared plus 6x plus 3 is greater than 0. So -3 squared plus 6 times -3 plus 8. -3 squared is 9. 6 times -3 is -18. So 9 minus 18 and then plus 8. -9 plus 8 is -1. But the inequality greater than 0, -1 greater than 0 is false. So none of the numbers between -4 and -2 are solutions. Then in the third interval, pick a number greater than -2, so we can pick x to be 0. I just want to point out, not that you have to worry about it, but you can use the original inequality. If you replace x with 0, you get -16 is less than 0. That's true. Compare that with using the other inequality. If you replace every x in this inequality with 0, you get 8 greater than 0, which is also true. The point I'm trying to make is when you pick a test point, you should get the same truth or false result regardless of which inequality you use. But anyway, every number in the third interval is also a solution. This time, since the inequality is just, the original is just a strict less than, that means the endpoints are excluded because it doesn't have the or equal to parts. So the endpoints are excluded. And so the interval notation parenthesis, -infinity, comma, -4, parenthesis, union, and then parenthesis, -2, comma, infinity. Then the algebraic notation, x is less than -4 or x is greater than -2. Okay, let's move on to the next page. Okay, find the distance between the points -4, 9 and 7, 5. So make sure if you use the distance formula, make sure that you memorize it precisely. The distance is equal to the distance formula for finding the distance between points x1, y1 and x2, y2. It's the square root of x2 minus x1 squared plus y2 minus y1 squared. When assigning x1, y1 and x2, y2, it doesn't matter which one you assign. But in using the distance formula, first let's focus on the x coordinates of the 2 points, -4 and 7. So inside the square root, we have the quantity -4 minus 7 squared. And then we add that to the other quantity. Now we focus on the y coordinates. The y coordinates are 9 and 5. So plus the quantity 9 minus 5 squared. And then we just do the arithmetic. Negative 4 minus 7 is negative 11. So negative 11 squared. 9 minus 5 is 4, so 4 squared. Negative 11 squared is 121. And 4 squared is 16. So the distance we get is the square root of 137. Okay, let's find the distance between these 2 points using the distance formula again. So the distance equals the square root of the quantities. So focus on the x coordinates. So 10 and negative 4. So we have the quantity 10 minus negative 4 squared, and then plus. Now we focus on the y coordinates, negative 6 and negative 2. So we have the quantity negative 6 minus negative 2 squared. All of that's inside the square root. 10 minus negative 4 is 10 plus 4, so we get 14 squared. Negative 6 minus negative 2 is negative 6 plus 2, which is negative 4, so we have negative 4 squared. 14 squared is 196 plus 16. The number negative 4 squared is 16. So we get the distance is the square root of 212. So this can be simplified because 4 times 53 is 212. So the square root of 4 is 2, and then times the square root of 53. So that's the distance. Okay, the next 5 problems have to do with circles. Write the standard equation of a circle centered at the ordered pair 7, negative 4 with radius square root of 3. So in general, the standard equation of a circle has this form: x minus h squared plus y minus k squared equals the radius squared. And the center is the ordered pair hk, and the radius is r. It's the square root of r squared. Okay, so if the center is the ordered pair 7, negative 4, we just write x minus 7 quantity squared plus y minus negative 4 quantity squared equals the radius squared. And we do want to simplify a little bit when we have such things like this, y minus negative 4. So we'll write this as x minus 7 quantity squared plus y plus 4 quantity squared. And then the square root of 3 squared is just 3. So this is the standard equation that we're looking for that circle. Okay, the next one is the same exercise. Write the standard equation of a circle with center negative 3, 2, and radius 9. So the x-coordinate of the center is negative 3, so we write in parentheses x minus negative 3, and then we square that quantity, and then we add that to y minus the y-coordinate squared, so y minus 2 quantity squared, and that's equal to the radius squared. The radius is 9, so we square the radius. And then in the next step, we just simplify a little bit. Instead of x minus -3, we simplified that to x plus 3 quantity squared. And the y minus 2 squared stays the way it is. And then 9 squared is 81. So here is the standard equation for that circle. Okay, on the next page, we start out with an equation of a circle that's not in standard form, but we can get it into standard form by, in the process, it will involve creating two perfect square trinomials. So here we have x squared minus 7x plus y squared plus 5y plus 11 equals 0. That is an equation of a circle, and we want to get it into standard form. So we'll rewrite this as x squared minus 7x. Leave some space and then write plus y squared plus 5y. Leave some space, and we're also going to subtract 11 from both sides. So for tomorrow's test, similar to what I talked about earlier, make sure that you write separate steps. Don't try to put all of the work in a single step. So this is a good first step. Then the next step, we're going to create two perfect square trinomials. We're going to add a number to both sides of the equation so that we get a perfect square trinomial when we add that number to x squared minus 7x. And we're going to add another number to both sides of the equation so that in the other case, we'll get a second perfect square trinomial. So we know how to do that. On x squared minus 7x, take half of -7, which is -7/2. And when you square -7/2, you get 49/4. So we add 49/4 to both sides. And then in the same second step, we can add a second number to both sides. This time we want to create a perfect square trinomial out of y squared plus 5y. So take half of 5, which is 5/2, and square it. When we square 5/2, we get 25/4. So we add 25/4 to both sides. And then we can write the standard form. X squared minus 7x plus 49/4 is a perfect square trinomial. So it's equal to the binomial x minus 7/2 squared. We have a second perfect square trinomial, y squared plus 5y plus 25/4. So that's equal to the binomial y plus 5/2 squared. And then we want to simplify the left-hand side. So we need a common denominator. So I'll replace -11 with -44/4 and add that to 49/4 plus 25/4. That part simplifies to 74/4. And then when we add these two, we just get 30/4. This can be written in lower terms to 15/2. Okay, one more thing, we'll identify the center. The x-coordinate of the center is positive 7/2, and the y-coordinate of the center is -5/2. And the radius is the square root of 15 halves. Okay, the next one, graph the circle x plus 4 squared plus y plus 3 squared equals 4. So the center is the ordered pair -4, -3. And the radius is the square root of 4, or 2. So this isn't too hard. First, let's identify the center, -4, -3. So the center, -4, -3. And then the radius is 2, so we just can find some points that are a distance of 2 from the center in both directions. And also in the vertical directions. So pretend like that's a circle. So the radius is 2. Here we have less than a minute, but I think that's enough time to at least get started on writing this equation in standard form, x squared plus 16x, put some space, and then plus y squared minus 14y, put some space, and then the equal sign, and then add 8 to both sides. So in the next step, we'll add 2 numbers to both sides of the equation. Complete the square on x squared plus 16x. Half of 16 is 8. 8 squared is 64, so we add 64 to both sides. Y squared minus 14y. Half of -14 is -7. -7 squared is plus 49. So let me write one more step, which is the standard equation. X plus 8 squared plus y minus 7 squared. And then we get 121, I think. 8 plus 64 is 72. Yeah, 121. Okay, that's all we have time for today. Remember, test 4 tomorrow. So go ahead and sign in for attendance.
How did we get?
2.